Welcome to another lesson. In today's lesson, we'll be learning about the Newton's first law of motion. Now, if you're a physics student, an engineering student, this concept is quite a core fundamental term that you should be familiar with. So what are we waiting for? Let's get started with the lesson. So we're going to examine Newton's first law of motion. Now, when it comes to the laws of motion, we have three main laws: Newton's first law, Newton's second law, and the third law. In this video, in this lesson, we're going to be learning about Newton's first law of motion. Newton's first law of motion, which states that an object at rest or moving with a constant velocity. I'm going to underline this because it's quite important. Will remain in its current state, unless acted upon by an unbalanced force. So what does that mean? Let's say you have a block. Now at this point we're quite familiar with the block example, and where we use it for multiple physics explanations because it's quite simplistic in nature and provides the complete picture. So let's say I have this block. Now this block is resting on the ground. It's not moving. Let's say velocity is 0 meters per second. This block will remain in its current state without moving, without being transitioning from one state to the other. It will not roll by itself. It will not float or levitate. Nothing will happen to it. You're simply going to be leaving the block on the ground. It's going to be in this current state forever until you either push the block, kick the block, pick the block, or let's say you hammer or destroy the block. In other words, you're applying an external unbalanced force. Now, what do we mean by balance and unbalanced forces? This is covered in another lesson where we introduced the concept of the force. To just summarize the concept to help you bridge the gap, when we have a balanced force, a set of forces, it means these forces, they cancel each other out. Let's say I'm going to be pushing the block with 2 newtons. I'm going to be pushing it in the other direction with 2 newtons. What's going to be happening in this case? These forces, they are going to be canceling each other out because they are balanced. So it's as if nothing is acting on the block. However, if I have 3 newtons here, this block will be moving to the right side because I have 1 newton more than the force acting on the right hand side. So 3 newtons minus 2 newtons, it will give me 1 newton, which is going to be the one responsible for moving the block. So Newton's first law, it mainly revolves around the fact that if I have an object in a state, it will remain in its current state until it's acted upon by an unbalanced force, which is going to cause the state to change. If we have a balanced set of forces, they're going to be canceling each other out as if we have no forces acting at all. In other words, we're going to be having the sum of the forces equals to 0. All the forces will cancel each other out, nothing will happen, and the block will remain in its current state. So this is the first case that we have for Newton's first law. Now the second case would be, let's assume the same block is moving to the right with a constant velocity of 2 meters per second. Now this is the second state. the same block is moving, let's say, to the right with 2 meters per second. The block will remain in this current state unless acted upon by the unbalanced forces as well. So what does that mean? Let's say I have this block and it's moving to the right side with 2 meters per second. Now I apply 2 newtons to the right and 2 newtons to the left. Obviously, these 2 newtons, because they're in opposite directions, they're going to be canceling each other out. So in other words, the sum of the forces equals to 0 newtons. The net force acting on this block is 0 newtons, as if there's nothing acting on the block, and all the forces, they cancel each other out, and there's nothing to cause these 2 meters per second, which is the velocity, to change. So these are the two cases that revolve around Newton's first law. If we have an object which is at rest and it's not moving, it will remain in its current state unless it's acted upon by an unbalanced force. And this is case number 1, where we had the example of a block. You are simply pushing the block with different forces, and all of them, they cancel each other out. Or if you have no forces at all, the net force is going to be 0. The block will remain at rest forever unless there's an external force acting on it to cause this change. The second case would be moving with a constant velocity, and when we say constant velocity, it means the net force is also 0, which is similar to the first case, where we don't have a net force acting on the object to cause the change in this velocity. In other words, to cause the acceleration, as we're going to be seeing in Newton's second law, which is the transition from the first toward the second. So when we have a constant velocity, it means the net force acting on the object is 0, and the object will continue on moving with the same conditions, with the same state forever, unless it's acted on by unbalanced forces. A great example for the movement with a constant velocity would be the satellite. Now, if you do have a satellite which is orbiting the Earth, normally it does that with a constant velocity, and because it's in space, there are no external forces to cause the satellite to move with a different velocity. So it continues its motion around Earth over and over again with the same velocity without any changes, fulfilling Newton's first law. So this concludes that for this current lesson, which is Newton's first law of motion. In the upcoming lesson, we're going to be taking a look at Newton's second law and Newton's third law. So I truly hope that you found the lesson beneficial. Make sure that you subscribe to the channel, because this lesson is part of a sequel, because we're talking about Newton's second law, third law. All of them, they are related to the same concept. So make sure that you stay tuned by joining our channel, and I'll see you in the next class.